Hello everyone, welcome back to my channel. In this video, we will try to see the beauty of distance time graphs as well as velocity time graphs. So these graphs gives us very valuable information about the motion of an object in kinematics. So here, if you observe, I took four graphs. In these four graphs, we considered the distance traveled by an object from the origin or from the reference point. The distance is considered on the y-axis and time is on the x-axis we consider. Now, if you observe the first graph, see, let's see one by one, means what is the information that each and every graph is giving us. Okay, so if you see the first graph, here the graph is a straight line which is parallel to horizontal axis or time axis. So what is the information that gives us? See, this vertical height gives us some distance. For example, if I take this as a reference point or origin, from origin the object initially is at some distance. Let us say this is the distance. Here is a object initially at t is equal to 0 seconds. Now, even though the time is changing continuously, okay, or increasing continuously, you can observe that the graph is a constant, means it is a graph which is parallel to time axis, means the distance is constant. So it indicates that whatever is the position of the object at t is equal to 0 seconds, you have the same position even at t is equal to maybe 10 minutes, maybe 20 minutes. You can, according to the scale, if you consider here it has 10 minute and here it has 20, here has 30. So after 30 minutes, after 40 minutes, it is at the same position. So what we can say that if the object position is not changing with respect to time, we call that the body is at rest. We say that the body is at rest. So in order to show the body is at rest, you can simply draw this graph. Okay, so it says that the body is at rest. Okay, so this is the valuable information that this graph is giving. Next, coming to the second graph, here the straight line, it is also a straight line, but it is passing through origin. If you observe this linear relation, means there is a linear relation between distance and time. So that linear relation says that it is covering equal distances in equal intervals of time, because if you find the slope of this line anywhere, you can see that the slope is same. Okay, slope here, in case of distance time graph, slope is nothing but change in distance. So in distance time graphs, slope is nothing but change in distance by change in time, or distance by time. Okay, so here the slope is constant everywhere when you measure here. So we can say that the body is having uniform motion, or the body is moving with uniform speed. This is the information that this second graph is giving to us. Similarly, if you see third and fourth graphs, these are just parabolas, and this parabola is opened upwards and this parabola is opened downwards. Now, as I said earlier, just the slope of a distance time graph gives us speed. Okay, now if you observe for the third graph, if you find the slope at the initial stages, this means how can you find the slope of a curve? So you need to draw a tangent at any point on the curve, and finding the slope of that tangent gives us the slope of the curve. So for example, if I draw a tangent at this point, so and finding the slope of this tangent, I can get what is the change in speed with respect to time at this point. So specifically saying we can get instantaneous speed we can obtain from this situation. Okay, so if you observe, when you consider different points on the curve, and at a different points, if you are going to draw a tangent and finding the slope of that tangents, you can observe that the slope is increasing. So slope means, already I told you, slope of distance time graph gives us a speed. So it indicates that the speed is increasing. Okay, speed is continuously increasing. Basically, the third graph and fourth graph shows that the body is in non-uniform motion, and specifically the third graph indicates that the speed is increasing with respect to time. Means it is, let us say, it is accelerating, we can say that. Okay, similarly, if you go for fourth graph, initially, at the initial stages of time, if you take a point and draw a tangent at this point, and finding the slope of that line gives us change in distance with respect to change in time, which is the speed. You can clearly observe that the slope from the initial point to the final point is slowly getting reduced. Okay, so here the slope is decreasing. Slope is decreasing, it indicates that the speed is decreasing. So it kind of somewhat decelerating, so speed is decreasing. Okay, so speed is decreasing. Now, from these four graphs, we can get some valuable information, like if a line is parallel to time axis in a distance versus time graph, if the graph is parallel to time axis, we can say that the body is at rest. Similarly, if the graph of distance time is a straight line passing through origin, then we can say that the body is in uniform motion. And if it is a parabola, we can conclude it as a non-uniform motion. And if the parabola is turning upwards, it indicates that the speed is increasing. And if the parabola is turning downwards, it indicates the speed is decreasing. Okay, so if you analyze the graphs in this way, you can understand the parameters of motion easily, so that you can get some fun in this in the learning process. Okay, so I hope you enjoyed this video. If you really like this video and want some more stuff, try to subscribe to my channel and hit a like button. Thank you very much for your patience.